You want to find network errors fast and need a reliable tool. Now what? You are not alone. Try Fiddler Everywhere free for 30 days and let this all-in-one web debugging solution deliver the successful outcomes you expect. Learn more at Telerik.com/Fiddler.
Hello, and thank you for joining us on another episode of the InfoQ podcast. Today we're bringing you a panel discussion recorded at QCon Plus. Wes Reisz moderated the discussion of event-driven architectures of scale. He and the guests cover everything from the importance of defining your events and domain boundaries correctly to monitoring, observing, and operating a large-scale EDA, and wrap up with some guidance on when the complexity of an EDA might not be the right decision. We hope you'll enjoy this fun and insightful discussion.
Hello and welcome to our panel on architectures you've always wondered about. The panel is called Event-Driven Architectures of Scale. My name is Wes Reisz and I'll be your moderator today. When you think an event-driven architecture, what comes to mind? Is it the benefits of scale, performance, flexibility? Maybe you think of a particular problem that you might be experiencing. Gwen talked about someone in her talk a little while ago. Maybe you think of it in terms of technology, say serverless or stream processing, something like Kafka maybe. Regardless of how you think about event-driven architectures, you probably have some questions. Today, we're going to dive into the topic of event-driven systems, and we're going to talk to a panel of experts who've been operating them at scale and have lots of great experience. So I'm joined by three incredible leaders in software. They come from places that operate some of the largest and most well-known systems in software today. I'm going to start off with some introductions. As I mentioned, my name is Wes Reisz. I'm a platform architect with VMware and working on Tanzu. I chair the QCon San Francisco Software Conference, and I'm lucky enough to be one of the co-hosts for the InfoQ podcast. So now let's meet our guests. So Gwen, I'm going to kick it off to you. And what I'd like you to do is introduce yourself and maybe talk a little bit about the systems you build. And then how did you land on event-driven? What brought you there?
Basically, I am a software engineer, principal engineer at Confluent. I lead the cloud-native Kafka team. So we're running Kafka as a service at a large scale for our customers. And before that, I was an engineer and I was a committer on Apache Kafka. So I guess how we landed on event-driven, basically after we tried everything else. So not exactly like that. So I spent a lot of time with our customers who were already using Kafka for event-driven. And so I kind of got to learn the patterns with my customers and how they solved problems, what problems it solved, what it created. And then when I started managing the Kafka in the cloud team, we kind of found ourselves with a monolith and we knew we have to solve it. Like you always start with a monolith. They're very fast to write. And we knew we wanted something better and we kind of had a bunch of different options. The thing that really got us to event-driven was the fact that it looked like it will allow us to avoid finger pointing between teams because everything is through events, it's recorded forever. You can actually see what messages were sent and reconstruct the whole logic and flow of the system if needed on a staging environment. So you can actually, like you saw something in production, it wasn't what you expect. You can actually take the entire topic of events and see what happens in another system. Yeah. And for us, it was huge. It's not like, oh, this is my responsibility, your responsibility. We kind of got to really well define, this is what you own, these are the events you react to, and we can take it from there.
Yeah, that brings up a lot of other questions, though, right? On how things actually react to all those events and how they're choreographed. Ian, what about you?
Hey, Wes. Hey, everyone. So I am a senior principal engineer working for Flutter International, which is the current incarnation of a job I started 7 years ago working for Skybet. So I'm in the sort of betting and gaming industry. And over the years, I guess I've worked on Skybet, BetStars, and now latterly PokerStars Sports. So I've got a few different angles from an event-driven sort of point of view. I guess one of the ones that I'd be quite interested to learn more about myself is how PokerStars has grown over the years, because that's one of the biggest sort of real-time event-driven systems I think probably exists around the place. So I guess my history, I joined Skybet back in 2014, and the main thing that we'd adopted then was kind of a pattern to take data out of a monolithic system, a massive Infomix database, and spread it out to engineering teams within the organization to allow them to have control of the data, and then they could build front ends that would scale. And I guess since then, I've worked on various other incarnations of systems, including some backed by Kafka that have been quite successful, looking at how we can actually use it to manage state in its own right, which has been a really interesting journey. So yeah, I guess quite a lot of different angles. One of the things that we've been working on recently is looking at how we use real-time events across sort of front ends, taking our sort of poker heritage, I guess, and bringing that to sports betting and gaming.
Nice. Matthew?
So I'm Matthew, I'm head of architecture at the BBC, and I'm sure everyone knows BBC. We have dozens of websites and apps, and with that, goodness knows how many hundreds of services. It's quite a broad range of things. It's quite fun to keep on top of, but lots of microservice thinking, lots of cloud-based thinking, so event-based architectures have to fall into that, right? It's not a dogmatic thing. It's not that we use that everywhere. A lot of the time, request-based is a better solution, right? As always, there's pros and cons, but event-based has to play a part, right? It has so many advantages, and fundamentally, if you have something like a search engine or a recommendation engine, it isn't going to fill itself, right? And so you need those events to come in and populate it so it becomes a good service.
So one of the first questions that I wanted to start off with, or maybe just some things you didn't expect when you went into event-driven systems, some things that maybe caught you by surprise. So this is early on in your journey, and I'll give you one example from my own viewpoint. I found that when I used event-driven systems that I had to really know the domain extremely well before I got involved to really understand kind of that choreography that was happening. Gwen, you talked a bit about choreography and orchestration in your talk. What is the importance of, I guess, really knowing the domain model, for example, when you're working with an event-driven system?
Yeah, I think, and especially as an architect who kind of try to advise other teams, you also have to know what you don't know, right? And kind of like a lot of your job is to draw the boundaries of the thing and kind of say, okay, this is what you own and don't step outside. If you want to do something outside, you send a message, someone else will own it. Trust them to do the right things, they own their domain. And this kind of level of trust is something like, it's kind of funny, right, how the culture and the architecture work together, because if you try to write an orchestrated system versus a choreograph, you actually have to know everyone's logic. You are the one who kind of like, okay, I'll call this, and this will happen, and then we'll call the other thing, and if this fails, I have to call the third thing. And so I feel like in many ways, a culture of choreography means that you are an expert in your domain, you define the boundaries, and then you don't have to worry about other domains. There will be other experts and you can trust them for that. And I think it's kind of a good company culture.
Yeah, makes sense. Ian, what are some of the things that surprised you when you started working with event-driven systems from maybe a more classic monolithic type system?
I think the big one that seems to come up time and time again is moving from this idea of something being synchronous to something having the time axis as well to consider. And especially when you've got potentially disparate data sources or different disparate producers of data and thinking about, is this actually happening before that? Or how do I handle this? And then I guess moving on from that to thinking, what happens if I see this event twice? Or what happens if I never saw it? Like, how do I reconcile my consistency after time? You can see that all over the place. If you look at it just in terms of like people moving from synchronous to asynchronous programming models, just within a monolith, you've got similar situations, I guess. But when that's also distributed across different systems and you've got to work out, how do I go and inspect that data? Or how do I see when this thing happened in another system or play back a log? You know, that's quite challenging. I'd say, yeah, probably the time element.
Sure. Matthew, any thoughts?
Yeah, I agree with all that's said, right? Yeah, the understanding the state of what things are at, right? And whether you've lost something or whether you've got a race condition, these things are seriously hard, seriously quickly, don't they? I mean, we talk about how stateless is a wonderful paradigm, right? And get that with the serverless functions, right? They don't need to care, right? They just worry about the current moment. Whereas in a world where you're event-driven and you have your microservice, it's got an awful lot of state, right? It's received a lot of events. If you've lost some, you're in trouble, right? It might have to pass it on to something else. What happens if that fails or needs a redeployment or something? Suddenly you look at this and go, this isn't the trivial problem, this isn't the dream, right? When I moved from that classic REST API that I was very happy with, it was very simple. Suddenly this isn't the panacea, is it? It's got all kinds of challenges.
So one of the questions that was asked that people wanted to learn is how to deal with things like those unordered events. Ian, you talked a little bit about having to deal with different events that may come in at different times. How do you deal with this idea that an event may not necessarily show up in this synchronous order events? How do you deal with something like that?
Well, for us, when we were looking at this, I guess the most important place it came up was in bet placement, which is like someone's actually spending some money with you. And I guess the key word that gets tossed around is idempotency and making sure that your events can be replayed without severe consequence, especially financial ones. So it's a case of education, really. It's understanding that it's a possibility and designing the system with that in mind, as I guess with most things. But yeah, we have lots of things that we have to think about in terms of if we've got this event multiple times, how do we discard things? If we haven't seen it, how do we play back or push new events into the system to try and get the consistency correct? I know one of the biggest pushbacks that we had from some of our operations people was whether this is right or wrong to do in production or what have you. You make up your own mind. But if you've got a database and your data is inconsistent, then you at least have the ability to go in and tweak it. You can run some SQL commands and I can fix this. When you're relying on an event log being played back, you've got to think about what's that control plane look like? What's my method to sort of get myself back into a good state?
Yeah, Gwen, what do you suggest on having people think about to get yourself back into a good known state?
Yeah, I am a big believer in making sure everything is idempotent and you go a bit farther back and trust that if you replay it will not get you into a worse state. I have to say, if in my mind, the biggest blocker to really doing async events is not really that the async events are that hard, is that people did not deep down accept that this is the only way. Like doing something synchronous and doing something that scales and doing something that has good performance, you are not going to get all three, basically. Like you can be synchronous and high performance, but this will not scale. You can be synchronous and try to scale, but you'll have very large queues. It's not going to be very good performance. If you want something that's performant and scale, you have to be async. So once you start kind of going, okay, I have to do it, then really, okay, is it that hard to have a idempotent event? It's usually not that hard. It's just that I'm in a new world and I'm not trying to create my old world with new tools. I'm actually in a new world now.
So Nandeep asks a question around well-defined business processes. What I read when I see this is choreography versus orchestration, back to what we were talking about a little bit ago. Is there always a case where everything should be choreography, or are there cases when we need that well-defined orchestration that has individual steps? Matthew?
There's never one right answer, right? We've got
Sure.
a bit of both, right? So sometimes you can override it with an orchestration setup, other times not. What you have to do to kind of pick up what we were saying before is assume that you will at some point get replays, right? No matter what you use, you are going to find bugs in your messages, for example, where you need to replay things. So even if your technology is very good at routing the right things to the right place and guaranteeing at least once consistency, you are going to have to handle that repetition of content at some point, right? Because it's just going to be part of what you do.
Ian, Gwen, any thoughts?
I really like Jan Choi's kind of compromise on this one, which is within the context of like a bounded context, orchestration is probably the right thing to do. But when you're looking at communication between different contexts, that's when the event-driven choreography really comes to play, and it's powerful then. I mean, it's still not a complete slam dunk, of course, but I think that's probably a really good sort of starting point for a definition.
Yeah, that's a good one. That's exactly what was in my mind too, Jan Choi's. He's got a great blog post out there that kind of dives into this if you want a little bit more about the differences between the two. Gwen, there's a question here about separating events and how you really start to think about your topics. When someone comes up to you and is asking about separating events and creating topics on Kafka architecture, how do you talk to them about that? What do you tell them to think about? What do you tell them to consider?
Yeah, it's interesting because I used to answer those questions for databases, like and what should be in the same table and what should be like separate dimension. And it just feels like the same thing keeps coming back. So first of all, like getting a good, very old school book on data modeling basically never hurts. That always feel like modeling is modeling, and you kind of have the domain-driven model design book, and then on the other hand, you have one of the old school data warehouse modeling or data modeling systems. And the thing that in Kafka you want to take into account is a bit of the scale requirements. So that's the thing that it does slightly different. Like if some kind of event is just super common, then you probably want to kind of separate, like, the main measurement and metrics event topics from things that are slightly more infrequent, because they will probably be processed separately and you'll want to react to them on different timelines. The other important thing is really the ordering guarantees, which doesn't happen in databases. If stuff is in different topics, then you will have no control over what orders are in. They could be processed in any order, and you need to be okay with that. If you want things to be in one order, you kind of put them on the same topic, on the same partition, and you have the strong ordering guarantees right there. And then a lot of it is just business logic. Like I saw a question passing by about how big an event should be. And like, it's like how big a function should be. Like, yeah, if it gets overly big, it's probably a smell, but at the end of the day, it's, do you have good boundaries for your model? Like, is an event an actual something that is a real world event in your business? Does it kind of align to some kind of a business thing that is going on? And that's kind of the main consideration. You don't want to artificially chop things up in different ways.
Yeah, makes sense.
We used to have quite a lot of conversations with engineers who are looking specifically around Kafka and Kafka streams and understanding how their topic design affected their streams app, because there are quite a lot of long-term implications, specifically if you're using it for storing state, I guess, and compacted topics. And people were getting the wrong number of partitions set up from the beginning.
One thing that I kind of caution people around, and also internally and also my product managers, you don't want to turn temporary limitations into a religion. So you kind of like, if you think the right business thing to do is something, but you have to make a compromise because the technology forces a compromise, you kind of want to very clearly document, we wanted to do X, but it was actually impossible, because then you don't know, maybe a year from now, X will be possible, and you can go back to it. For example, Kafka used to have limit on number of partitions. It's long gone, and it's in the process of being even more gone. But people designed an entire world ideology around it, and it's very hard to tell that, do you do it because it's the right thing or because you believe in a limitation that actually no longer exists?
Yeah. Ian, I want you to double click on that a minute. So you said long tail implications of your topic design. Like what? Describe that a little bit more.
Well, I guess sometimes it's a bit of a naivety in terms of like thinking how easy it is to change things after the fact and looking at the throughput that you might need. I guess to something that Gwen touched on there about the size of an event, if your events get too big, there are issues with the sort of replication model that you want to have and how much traffic you're going to be sending between brokers. But the main thing for us was that if we were holding our state in a compacted topic, and then you suddenly realize, hold on, we didn't have enough partitions to support the throughput that we've now got as this has grown, all of those previous events will be on the wrong partition if you try and widen it out. So you've got to play through with people. Like, how are you actually intending to scale this up if you need to in the future? Are you aware of what the constraints are of your choice now? And I guess we tend to try and model things in that sort of Amazon type 1, type 2 kind of framing, you know, like, is this something you can just sort of do for now and not worry about it? It will change easily in the future. And that's one of those ones where I think if you don't necessarily have enough understanding of how the systems work or the actual technology you're working with work, you can turn a type 2 thing into type 1 quite easily without really meaning to. And it's making sure people are aware that look, this is a constraint. Just keep it in mind when you're designing your system and how you're putting your data through this technology.
And indeed, I find that even it's a great type 1, type 2 thing, isn't it? Right? There's this idea, right, that how sure, is this a reversible decision? And that's one of the challenges I do have with event-driven architectures per se, is it can lock you into things that are hard to change later. Once you've got multiple clients that are now accepting your events, changing that event format becomes a really tricky thing to do. You hope that you can add new fields to your JSON or whatever without your clients caring, but that always still feels a very nervous thing to do, and I don't think we've quite worked out how you handle that problem.
There is a book on that, right?
I was going to say, let's talk about that. Actually, let's talk about that, Gwen, because there were some questions that came up. How do you address problems like that? Sorry, I stepped over you, Gwen, but you talked about a book?
Yeah, so I think it was by Gray Young, if I remember the name correctly. He wrote an entire book on event versioning, which kind of just goes to show that it's not an easy problem, and I'm not going to solve it for you in 5 minutes right now. Kafka is well known, like internally on its own protocol, for being fanatical about compatibility. And you can take like a 0.8 broker and a 3.0 producer and a 1.0 consumer and just have it all work. But it comes at a cost in which you evolve things incredibly slowly, and every client and every application has a big, if you get events of version 1, if you get events of version 2. Like, it's kind of highly non-magical, I would say.
So this morning, Catherine Probst in her keynote mentioned a bunch of day 2 operations things for microservices. She listed some things like load testing, chaos engineering, AI ops, monitoring. I'm curious, when we talk about event-driven systems, what are some day 2 concerns that you need to be thinking about? We talked about versioning, for example. Matt, I'll start with you, but what are some things that you need to be thinking about that you maybe don't really consider right off the bat?
A couple that come to mind. Scale is definitely one of them, right? What happens if a large number of events have been republished? And often you find, if you're a microservice owner, you might find that one of your event suppliers is suddenly choosing to republish some things for whatever reason, right? Maybe they had a bug or some things. You need to be able to handle that. Or at the very least, you probably have a queue in front of you from which you can handle that backlog, right? But you do not want that backlog to last a particularly long time. So you have an interesting scale challenge, which from nowhere all the traffic can come from, right? All those events. What was the other one? Just the fact that you're storing that state, right? How are you storing that? And what happens if you redeploy yourself? Are you making sure that you're not dropping anything during those moments?
Ian, what are your thoughts?
I completely agree with both of those. Perhaps one of the ones that I've noticed over time is less day 2, but more like day 600, when the people who built the system have moved on, and the fear of new people coming in and trying to work out how this thing works and not being able to change things particularly, and being worried. Like, a lot of it becomes around, like, I guess what you mentioned at the start, the domain, and how is it documented? How are people able to change things? What's it like to actually come in cold and try and adopt this system and evolve it to suit the current needs of the company?
Gwen, any thoughts from you?
Yeah, I feel like my day 2 events are, we should have done it in day 0 kind of things. But test framework, like, you have all those microservices, you're going to upgrade them independently. People kind of talked about building confidence. So really, you make a change, you want to have a test framework that A, will not take too long to run, maybe an hour or 2, but not that much longer. B, mostly reliable pass, like it should have few green beans every single day. And then 3, fairly easy to use and evolve and diagnose. And I discovered on day 2 that actually upgrades and releases are freaking hard, because we don't really have a great test framework. And now we have to basically stop a bunch of production projects, go back to the drawing board and ask ourselves, we have, like, 50, 60 services. We're not even that large. How do we actually test scenarios that involve all of them to be confident that we did not break anything unexpected?
Yeah, there's a bunch of questions here around kind of observability, monitoring, and things like that. So I want to shift over and just give each of you an opportunity to talk a little bit about the importance of observability, monitoring, event-driven systems, and any tools. I think, Ian, when we were trading some emails, you talked about kind of day 2 ideas of actually building in some monitoring and types of tools into what you're working with. So I'd love to know some tips, tricks, and thoughts from each of you on monitoring and the event-driven system. Ian, I'll start with you.
Yeah, I guess some of the ones that gave us the most value were things like adding tracing, to be able to see the sort of lifetime of messages and records as they go through various parts of the system. And that, coupled with tools like Kibana, can be really powerful to understand exactly how things are moving, where your bottlenecks are. One of the questions that we constantly got asked was, have we seen this? Because I guess one of the things you don't always have the luxury of is that you're the producer that's the source of events. Like, for us, we take a lot of data from third-party suppliers that have scouts at football matches and publishing updates, and we just don't often know, has this happened? That we should have seen that the score on this football match has reached 3-0 or whatever, but we don't have that state. So what events have we seen? What order? And I think we built some tooling that allowed us to really quickly kind of dive onto a production box and play back some events. But I guess the things that always tripped us up before we kind of spent the time to build internal tooling around this was we wanted to have TLS between, this was Kafka specific, so we have TLS between the broker and the clients. And that enforced our ACL, so you might not have permissions to see certain topics. You've got to think about that, what you're doing there. If you do have some sort of debug facility, make sure you're not going to be messing with your actual production consumers, so that they're not getting fizzed around all over the place, and making sure you're considering like how it actually will affect a working system. And then if ever we needed to extract data, normally, I don't know if everyone's systems are different, but we had like multiple levels of sort of jump hosts to get to our actual Kafka brokers. And then you're thinking, well, how do I actually extract useful information from this in a way that I can then take it away and triage it in a PIR or something like that? But it comes down to, like, you don't really find out your requirements until you kind of need them, and then it's making sure you've put the time aside and put the effort in place to kind of build the things that you need.
Yeah, your mileage may vary, absolutely. Matthew, anything that you all learned on the observability front that might be some good advice for other folks?
As Ian says, tracing is really good, isn't it? We do a lot with Amazon X-Ray, and it works very well. Obviously, and then individually at each microservice level, you're getting the logging right so you can diagnose where there are issues. And as long as you've got some kind of broker in between each microservice, be it Kafka or Kinesis or whatever, then you hopefully can discover and isolate which is the one microservice that's letting you down, and address it as quick as you can.
Gwen, anything from you?
All good advice. The only thing I have to add is maybe the idea of sampling, that you can have an external system that will sample some of the events, especially if everything that's going on is very high scale. And then kind of double check it in the background for outliers and that nothing unexpected, like things are not overly large. You kind of know, and I think Ian just spoke to it, you kind of know what the shape of your data should be like. And that's kind of how you detect if we should have seen this and it's not here kind of things. We also know that we should not expect that many authorization attempts a second. And if we get that, probably something went terribly wrong. So we kind of have built these systems that goes in the background and double checks some rules on samples. And I think that served us quite well.
So, Gwen, I'm going to start with you on this one because I think you already mentioned one, but there were a lot of requests for different war stories that led you to some different lessons. So we'll kind of go around the horn again and ask everybody. But what is, I guess, some lessons that you learned the hard way through some war stories? So tell us about the war story and maybe the lesson.
Yeah, I think that's the one that kind of relates to the versioning discussion from earlier. We basically wanted to upgrade a lot of a single, like we had about 1,000 instances of a single service type, and we wanted to just upgrade them. And it's a stateless service, which makes it easy. We just pushed about 1,000 upgrade events through our pipeline, hoping that it will all get processed. And 997 of them managed to, over time, upgrade themselves. And 3 wouldn't. And we couldn't even really see why. Like the event was getting there, everything looked fine. Like we had traces, we had the logs everywhere. And eventually we discovered that those were like our 3 oldest services, basically. Like the first 3 customers we've ever had. Like I think dating back to like 2017, they had some kind of a different authorization key that prevented them from downloading the things they needed to download in order to upgrade themselves. Nobody even remembered like exactly how the key got there, and apparently it was a different type of event. It was just 3. We ended up brute forcing them, but that's kind of the thing, right? Even if you're very careful about evolution, one step at a time, you kind of evolve away into a system that will be totally incompatible with whatever happened in 2017 that nobody even remembers. And so I think that the main lesson here is just don't have anything that is that old. Like everything has to be upgraded every 3 months, 6 months, maybe a bit longer if you have less churn in what projects you work on. But yeah.
Ian, what about you? Tell us some more stories.
Yeah, I've got a couple that sort of sprang to mind as you asked that. They're both from a few years ago, so I don't think I'm hurting anybody's feelings by saying these. But one of them was precisely about the sort of size of events, or rather the size of things linked to an event. So we had on Skybet, one of the ways that pages are built is that this flow of information out of Infomex comes through, goes through various Rabbit MQs and then processed by node and eventually gets stored in Mongo documents. And because of the way that the updates happened, we tended to read the document from Mongo, work out what that meant for the document, and then write it back. But there was a bug in that logic that meant that we didn't ever really delete stuff from the Mongo document. And because it was a homepage, I think it was the horse racing homepage on the site, it just gradually got bigger and bigger and bigger. And while it wasn't obvious straight away, when the site went down, unfortunately on Boxing Day, which is a pretty big day for sports betting in the UK, all these things were going wrong and we couldn't work out why. And it was basically because we saturated our network by pulling this document in and out of Mongo so frequently that we couldn't actually handle it anymore. So that was a pretty interesting day. The other one that I can think of that was quite difficult to work out and probably speaks to something around best practices with working with Kafka was that we had this really weird situation where we had 2 producers. So I guess that's your smell straight away. But we had 2 producers writing to a topic, but the records with the same key were ending up on different partitions. And the long and short of it was that basically one of them was a Node app and the other one was written in Kotlin. And the way that the key was used and the data type that was used to produce the actual partition hash meant that the integer was used in Kotlin and it overflowed. So it was actually producing a different hash to the Node.js one. And finding that was quite a day.
How did you find it?
Personally, I can't remember. It was a few years ago now, but I just remember looking at, we were just literally going line by line in these programs, like what is different? And the only thing that we ended up concluding was this one's Node and that one's basically the JVM. So what could possibly be different in the implementations? It's just a number.
So we're coming up on 5 minutes. So Matthew, I'm going to start with you. We're going to go around one more time. But again, we have about 5 minutes, so just keep that in mind with your answer. So what I want to ask you is I want to kind of focus on day 2. If you could sit down with someone and give them one piece of advice on what to think about for day 2 or kind of long-term operating of an event-driven system. We've been talking mostly about Kafka. What might you suggest? It doesn't necessarily have to be with Kafka, but what might you suggest to them?
Do your very best to keep things as simple as you possibly can, because it is extraordinary just how complicated these things get. The story I would have said if we had time was to talk about how we had one moment where we have all these different systems doing all these different events. Wouldn't it be great if we standardized the events and put them all together and made this one super topic of all the events? And of course, that was a terrible idea, right? Because they all have their different properties, right? Scale in different ways, needed in different ways. But just like the microservice concept, keep things separate, keep things simple. Don't just assume event-driven is the answer, because it's a great solution, but it's not always the right one. And just be aware it might not be as simple as it looks at first.
I know we're kind of wrapping up, but this is a question that came up we just didn't get to. As you go through final answering these things, what are some systems that maybe aren't the best for event-driven systems? Do you have any thoughts on that, Matthew?
Fundamentally, if yours is a user-facing thing, right, it ends with a request, doesn't it? Right, a user turning up going, give me a thing, right? So at some point, your event has to turn into a request bit. And it's all about working out where that is. The BBC, we prefer to have it so actually we do quite a lot request-based when the user comes in, so we can respond to who they are, right? We want to be dynamic in that regard. So that's one example, right? You can't realistically prepare it ahead of time because you want to respond to the moment.
Yeah. Ian, I totally changed the question on you, but what are some things that aren't great event-driven systems? And then what is your recommendation for someone for day 2?
Things that aren't great, I guess Matt's just summed it up nicely there. But I think one of the nice ways to think about it is if I've got a workflow and you want to be able to kind of identify all the steps in that workflow and keep an eye on it as a kind of deliberate entity, that's quite a nice way if that's orchestrated rather than event-driven. My advice, I guess, it's kind of similar. Don't force fit it where you don't need it, but also be quite deliberate in designing your data to allow it to evolve. And keep in mind the way that you are choosing to implement it. So I guess Amazon's a good example, like, do you need SNS or SQS or Kinesis? Think about the constraints of the actual broker and systems you're using and design for them rather than against them.
Awesome. And then Gwen, we'll wrap it up with you.
When not to use event-driven, I would almost say that start with not and look for the places where you need this level of reliability, auditability, replay, really strong decoupling, really large scale. And basically keep an eye on when you need event-driven rather than start there, because I do feel like it adds a layer of complexities that maybe you will never get there. Who knows, right? Maybe your startup will not be that successful. In terms of day 2, can I be slightly self-serving and say that you do have an option not to run Kafka yourself? And I mean, it just removes a bunch of pain, then hands it off to someone who is actually fairly excited and happy to take care of it. And I think it's true in general, like we don't do our own monitoring. We have a bunch of third parties, providers that do our monitoring for us. We don't run our own Kubernetes. We use AKS, EKS, GKS, all those. So basically it's kind of nice to have things that you don't have to worry about every once in a while.
Yeah. So there literally are probably 100 questions in here that we couldn't get to. But for my benefit, thank each of you for coming on here and doing this and subjecting yourself to the unknown on the questions that might be asked. So thank you for doing that. And I very much appreciate it.